Calculated value January 2017. So 2004. Okay, the time is 9 years. 1,000 investment. So your final value is 1,000 times time a to the 9. A is your accumulation function. To find a of 9, we have to find AT, which then is e to the integration into t. Delta r dr. And that's why you've been calculating a of 9 is e into the 0 to 9. And now it's okay to do delta t. So 0 and 1 t minus 1 to the power 8 dt. So like you said, the integration would be important. So we would integrate 0, 1 t minus 1 to the power 8 dt. We bring the 0.1 to the outside. If you integrate by power, it's t minus 1 to the power 9 over. We have to plug in the upper limit, lower limit, that's 0 to 9. So 0 and 9. So the first limit is 0.1 times 8 to the power 9 over 9 is upper limit. Lower limit is there. That's -1 to the power 9 over 9. It's a really large number, so it's 0.1 8 to the power 9 over 9 minus -1, so it's plus 1 over 9. That's the exponent part. Going back to here is equal to e to the 0.1 times 8 to the power 9 over 9 plus 1 over 9. And that's the A9. A9 is to multiply 1,000. So if we put it in here, it's 1,000 times. There's no E and E. Okay, so there's E to the power of 0.1. Just enter. It's 0.1 times 8 power 9 over 9 plus 1. Well, I switched this question. It was still a weird answer. Let me see the answer in the system. Was it in any way similar? See if there is any problem with the computation. Okay, maybe it's a reading that has the issue. Reading. 100. That's n minus 1 over n plus 1.
Yeah, the final answer looked like it took the accumulated value, so just like the A9,
No.
multiplied it by 100.
But it was 1,000. What did the 100 understand? Only plus 1 was that's n. Right, sometime. But weird. I don't see any calculation issue. Let me see the difference between. It's the same calculation for question 1, right? It was.
Yes, it was just the only difference with question 1 is that the powers were smaller and it was a smaller time frame.
Take that calculation earlier. Let's see the grading rules. That's the exponential function. This grading rule is fine. That seems to be the right rule. All right. I feel like maybe the question 3 has any problem with the design itself. Maybe I'll just get rid of it because it's the same calculation as question 1. I suspect there is a problem with the grading itself. Maybe that's why they have a longer time frame. They call it computation. Also, the force of interest function is defined. The design it shouldn't fit like a bigger time frame. That's why it would cause a problem. Right. Let me just remove that question altogether. That way we don't have any issue with the grading. So just go back and then that single question. It was the original question. Sorry. It's the same question. It's pretty much the same design, so it's not necessary to have it there. I think it's not being changed. So that way all your 6 questions is finished and I don't even have to change the dates. All right, we could continue where we left. I was trying to finish chapter 2 today. Do you have any question with the homework? If you okay with the later section of chapter 1 or chapter 2?
Yeah, I was able to finish all the chapters.
Okay.
Finishing on chapter.
Okay. Let's see how many questions have I assigned chapter 2. Or only assigned 2.3. The rest of them is supposed to be like still Yeah, the rest of them are 2.6 and 2.7. I didn't really assign anything for 2.5 and 6 since they're pretty much the similar content like 2.3. All right, so the whole chapter 2 focused on using the equation of value to solve related questions. Tyler, are you in? Oh yeah, you were here. Maybe we should try a practice question before we start with chapter 2. That's the question we did last time. This is calculate dollar weighted average rate of return. All right, we should really finish the chapter 2 and we can use that question for this. All right, so the chapter 2 focused on equation value. 2.1 introduced all the sections in chapter 2. It has 7 sections. 2.1 is introduction. 2.2 focused on equation value that has only one cash flow. We did a couple of exercise, calculate time, calculate interest. 2.3 is equation of value with multiple contribution, which we call C. Those are also the cash flow. And we had a couple examples drawing the timeline and the cash flow along the timeline. These are exercises we did. We slowly learning to use the cash flow worksheet on the calculator to get to utilize it for computation, especially when the polynomial has the right order. And all right, and then we move on to chapter 4. The title is called. We should start talking about. We ended with chapter 3. We start with this question. We try this question last time. I wonder if I finished 4 or 5. We did. All right. 2.4. The title called investment return. That is really figure out the internal rate of return. Essentially, that's the I in the formula for the equation value. And those are the exercise practice question. You can see sometimes we have an equation that is a higher order polynomial. In order to solve it, there's 2 methods that we can try. One way is to factor the polynomial completely. That will allow us to find the solution. Or we can use the BA2 plus calculator. Or we can use we can also use the Newton's method, approximation method, to determine the equation. Okay, let me move on to 2.5. The title is called reinvestment consideration. Are we there yet?
Thank you.
Okay, so reinvestment consideration is when you have you have money, you might consider put the money in the bank instead of leave it there with no change of value. So this example says we got 2 person, one person loans money to another person. Jose loans Martin 12,000. Martin repays the loan by paying 5,000 at the end of the 2 years and 10,000 at the end of 4 years. You can see the original loan was for 12,000. The repayment is actually 5 plus 10,000. It's actually 15,000. So slightly higher than the original loan, which makes sense because we got to pay the interest. All right. So then the money received at time 2 is immediately reinvested. So when the person are returning the money, repay the money, the person that loans out money to other person actually have a reinvestment plan in head, meaning that he's not letting the money sitting there with the same return. He decided to put in the reinvestment, and that rate of return is actually 2.4%. I find Martin's rate of return and Jose's annual yield rate. originally, if there's no reinvestment, then Jose's timeline and Martin's timeline will be identical, except one is positive, the other one negative. They're just opposite of each other. But now, because Jose decided to put the money that he received as payment into the bank at a certain rate of return, that made sure that his reinvestment has a set rate of return. That's 2.4%. So now the two persons are not facing the same timeline anymore. So let's look at these two timelines, one for Jose, one for Martin. Now for Jose, he loaned out money to Martin. So at time 0, you can see it's negative 12,000. That's when he giving out money. And then he received money at time 2, that's the 5,000, and received time again at time 4 for 10,000. So now we're gonna set up the equation of return for him. You see that we're setting up an equation for time 4. So at time 4, the 12,000 is going to grow at a rate of return that we do not know. Let me call that ij. So 12,000 multiplied by 1 plus ij at power 12. So the ij is what we're trying to solve. On the other hand, the 5,000 and 10,000. Yeah, it's actually 10,000, not 100,000. 5,000 and 10,000 are invested at a rate of return of 2.4%. So 1.024 is an increase by that factor. So from time 2 to time 4, it increased by 1.024 to the power 2. So at time 4, the 10,000 is still 10,000. So that will be the equation, the t equal to 4 equation for Jose. Solving the I4, we will have Jose's default rate of return. Any question? Right. The second equation is for Martin. There's no investment because all he has is the 12,000 that he borrowed for whatever reason. And then those money are being repaid. And then he have money out at time 4 and time 2 because he need to pay Jose. So if we are considering this, all these have the same rate of return for money. If we think there is also default, something that we didn't see. You see there's nothing else on the timeline. We're assuming there's no cash in or out, right? So then the money that is 12,000 is the same investment that he's paying the 5,000 and the 10,000. We're thinking the negative 5,000 and the negative 10,000 for Jose would have the same value as the 12,000 on the timeline of any point. So at t time t equal to 4, the 12,000 is increasing at 1 plus I to the power 4. That's because there are 4 years passed. And the 5,000, which will be negative 5,000 because that's time out. The time from 2 to 4 is 2. And then of course the negative 10,000 is giving out at time 4. That one do not have to multiply anything. So that will be that equation. Solving this equation, we will be able to find the I in this question. So that's the calculation. Because equation itself is different, and that's why we're definitely going to have a different rate of return for Jose and Martin. Any question? So that's the first equation. Solving the first one, it's algebra, right? There's only one variable. You would divide both sides by 12,000 and raise it to the power 1/2 and then minus 1. That's ij. The second equation is slightly harder, but there's degree 2, there's degree 4. You can assign x equal to 1 plus I squared. Then this equation will be 12,000 x squared minus 5,000 x minus 10,000 equal to 0. That will be switching it to a degree 2 format because we have an x equal to 1 plus I squared. That way we can solve the equation with Greenwich formula. So that's kind of the plan for the solving part. Did I actually put the answer in there? I didn't really put it in there, but that's really according to the timeline. That's how we set up the equation. That's the first example in this section, and we have our second example. All right, so that's whenever you have a reinvestment, it causes you to have to adjust your equation accordingly, and therefore you may have a different equation. So this is another example. We have Julie pays Chen 1,000. In return, he pays her 300 at the end of 1, 2, 3, 4 years. Okay, so whatever money you are borrowing, you probably have to return with a higher value. In this case, it's 300 each year. So 300 times 4, that's 12,000. Consider it's span for the 4 years, it's actually not that big deal, right? Right, the present 1,000, I think it would always will be more like urgent and more useful. So every time Julie received a payment, she reinvested it at 3%. So she decided not to let the money sit there and then reinvest it. And that will guarantee the rate of return for those cash flow. And find the annual effective interest rate by both of them. So we're actually setting 2 timelines for the 2 persons. One is for Chan. He has a 1,000 at time 0, and then he have negative 300 at 1, 2, 3, 4. And the equation up top will be his equation value, assuming the internal rate of return is I. And we have 1,000 and then 1 plus I to the power 4 and 300, 1 plus I to the power 3. There's like, this is a time 4 equation, 1, 2, 3, 4, 4 interval. And that's why we have those power. And so then the grand equation on top is for Chan. Question. Right, for Julie, only that 1,000 is unknown. We don't know the interest rate for that. But assuming these 1,000, this negative 1,000 is the reason for all the other 300 inputs. The 300 input has been reinvested, so they have a fixed rate of return. And then the 1 plus I is the default. So calculated, we will figure out what I exactly, if there's no other cash flow to help. And we're assuming this 1,000 is the reason for all those 300. That will allow us to calculate the I. That's what we call annual effective interest rate implied by the equation of value. Any question? All right. But normally real life is not that simplified. But this is just considering there's no other interruption or intervene. So cash flow. All right, so this one we actually have a numerical solution using the VA2 plus calculator. Chan's cash flow is about 3.71%. What we are doing is enter cash flow at time 0 is 1,000, C1 is negative 300, and that's being repeated 4 times. So the frequency for C01 is 4. That's all we have to do. And then you calculate IRR and compute CPT, it will show the same answer. So it's pretty easy to double check that. We only have to figure out, enter 3 value into the calculator to show the rate of return. This is the only one we should use the VA2 plus calculator because that's the degree 4 polynomial, which will be hard to do manually. On the Julie side, since there's only 1 variable with algebra, all we have to do is find summation of the rest and divide by 1,000 and raise it to the 1 over 4 power minus 1. So Julie, we can do a little bit algebra solving that 1 single variable. But for Chan, we definitely would prefer use the calculator to solve it. So this Chan's rate of return can be found using the VA2 plus calculator. All right, I'm gonna use a dollar-weighted yield rate question as our practice question for today on the paper. Now, the dollar-weighted yield rate is, see, many times after calculating the yield rate or cubism, and one might wish to find an elementary method, which means doesn't involve higher order polynomial solving. So essentially, dollar-weighted average, there's a way to find the interest rate for such as the earlier one, like that one or that one. So occasionally you see a situation that is difficult to do algebraically, and we are trying to find a close enough numerical answer. So that's why I remember one time you were asking me that question, we had a hard time finding it with the algebraic method. And then the method that we're doing eventually is doing the interest rate divided by the overall investment. That's our default interest rate. That's what it is. So dollar weighted average is a common way to find the interest rate when solving the equation itself is difficult. All right, so we have to figure out a way to analyze the question in the dollar yield rate formula. There are a couple of letters or formula component that we need to talk about. Number one, we define this in letter A. A represent the amount of money you have at t equals 0. And then we define the B. B represent the amount of money you have at the final time, t equal 1. All right, we define the net contribution to the fund by summation of all CK. CK means the contribution C. So that happened at time K. And I denote the interest rate. I is interest rate. So we have this equation that goes B equal to A plus C plus I. So your balance at the end of the 1 year, at end of time, is equal to original deposit plus the contribution cash flow plus the interest. So then we often find that the final balance does not equal original deposit plus all the money that we saved. The reason that you have cash, you have interest, right? Right. The A is the original deposit. The C is along the line. You have a couple of CK, a couple of contribution. But most of the time, B does not equal A plus C because there's this time value. Value of time is what we call interest rate. Right, so remember that equation. That will be something we go back and forth when they're trying to handle the equation. All right, the top equation says B equal to A plus C plus I. And then we have this formula that says, so what happened to the, assuming that the investment period is 0 to 1, assuming the interest rate is J. So essentially we figure out a way to calculate J. So your deposit A is happened at time 0. So by the time it reached time 1, then A multiplied by J is the interest rate that is in part or that caused by the money A, right? A times J, that's your interest because the J is the interest rate whole time period. And then we have to talk about what about the interest rate of all those small contributions along the timeline. So assuming that you have a couple of contributions happen at time T, so CT represent the cash flow at time T, and then you're gonna have to multiply by the growth factor. If it's go from time 0 to time 1, of course, the whole interest rate will be 1 plus J. But it didn't, right? It happened at time T. So it only lasted from T to 1. So the actual time frame is 1 minus T. So your 1 plus I have to raise to the power 1 minus T. That's the growth factor. But see here, we're not calculating the balance. We're calculating the interest rate. So the final balance is say T times 1 plus J to the 1 minus T power. But then you have to minus 1 just so to find out the interest rate. So in the bracket is the interest rate, and the interest rate multiplied by the contribution. That's the interest. So essentially the second formula 2.6.2 is a way to calculate interest, like the total interest at the end of the whole year. Okay, but there's a small problem because this will cause us being, since the power 1 minus T is a fraction, like T is any time between 0 and 1. So T is a fraction, 1 minus T will be also a fraction. This is a fractional power to the 1 plus J. So this is a nonlinear equation. If we want to solve this equation for J, we will have a hard time for that 1 plus J to the 1 minus T power. Instead, this formula follow compound interest formula, assuming the interest is interest rate J. So we're doing a simple interest in this replacement. Not only we consider the simple interest have a similar value like the compound interest. So we would say in the bracket, that's a compound interest calculation for the interest. Now, if it's a simple interest, all you have to do is interest rate times the time frame. The entire time frame is 0 to 1, so the interest rate is J. C times J will be it. But if it's not lasting the whole time frame, all you have to do is look for the time frame. The time frame for the say T is from time T to time 1, so that's a fraction of the whole time frame. So J times 1 minus T is how we calculate that time frame. So what 2.6.3 is explaining a conversion from compound interest to simple interest. Changing that part, we now have the 2.6.4, right? From that, we can calculate the J. We'll factor the J as a common factor, divide both side equation with a coefficient, and you have the J formula at the last. So the bottom equation, essentially that is our dollar weighted average interest rate calculation, assuming you have I, A, C. Any question? Okay, so obviously this interest rate is calculated based on the simple interest formula. Chances are it won't be identical to the true interest if it's a compound interest. But as long as your time frame is short, then it's very likely it could be close enough. So that's the logic behind it. All right, so this is our dollar weighted yield formula we call JDW. J is similar letter like the I with a little J on the top just to differentiate with I, but not too different with I. DW represent dollar weighted, so JDW is the formula we're using so far. It was a formula in the previous slides, I over A plus summation of CT times 1 minus T. Essentially, it's interest rate divided by overall deposit. You know the A is deposit at time 0, so that is a contribution for the whole, right? For the whole investment. The cash flow that is deposited throughout the whole time frame should also be considered, but it only considered for the time frame where it's in the investment, right? So as you were considering, think about all the components, it's not too hard to remember the formula. So basically, we're saying whatever interest is being derived from all those deposit at the beginning and also deposit along the timeline. Okay. So having that in mind, you can try a few examples to do the calculation. Oh, there's a couple of conversion of it. All right, number one is what if you have a single deposit? If you have only one deposit, all you have to do is I over C times 1 minus C. So there's no more summation. Or even if you have multiple deposit, you could combine all those deposits to a single deposit to make sure they are equal. So it's possible all of these could equal that. And of course, then you have to find the perfect time to have the one single deposit equal to all the multiple cash flow. So that perfect number K is the same K that we mentioned in the earlier section. So the K there, we have a particular formula for its computation, which was, I think it was also a formula at the time. It was a weighted formula using the cash flow. All right, and then 2.6.8 is when you have, if you are deposited with one big deposit, that K can be, what is it? I think it's continuous from the formula over here. We're trying to revise it. The C is equal to B minus A minus I because B equal to C plus A plus I. So then the C actually equal to B minus A minus I. And then remember B basically is the total of ACI. So if you want to calculate C, B minus A minus I give you the C. And then you redistribute this and it looks like at the denominator is a component of A, B, and I. That's what happened. Okay, and then why do we want to derive all that since K is unknown? The last equation explains the reasoning. Maybe roughly speaking, the perfect timing for that one single cash flow is 1/2. So when K equal to 1/2, we have 1/2 A here, 1/2 there, 1/2 there. So these are all 1/2, and then as a combination, eventually we have this formula 2I over A plus B minus I. That is another approximation for J. It won't be as accurate as the original formula of dollar weighted average, but it will be a rough way to determine. This is whenever you have a hard time determining the contribution. I mean, this may be another way to find out. Any question? Right, so we apply some of these formula under different scenario. And let's look at one example, and then we probably could look over the quicker question as an exercise. Right, Martin's investment account had a balance of $10,210. He deposited $4,000 on March 1st, 1990, withdrew $3,000 on June 1st, 1990, and deposited $1,000 on December 1990. So essentially, they are all from the same year, January 1st till December 1st. At the end of 1990, Martin's balance was $12,982. Find Martin's dollar weighted yield for the year of 1990. So basically, it all happened in the whole year. That's why I started to label the time. Okay, so it's messy when you just read the whole scenario, but it will be a lot more clear if you have the whole timeline. So at time 0 at January 1st, that's before the whole year. So that's our time 0 and called it 10,210. Right, March 1st. Where is March 1st? March 1st is right between February and March, right? March 1st, I think it's roughly the same as like the February 28th, right? Right. So March 1st is when 2 months has passed, and there's 10 months that's coming, right? So I put a time 2/12 for the time. So that 4,000 is deposited at time 2/12. All right, and then withdrew 3,000 on June 1st. So what's June 1st? June 1st is the beginning of the 6 months, but it's the ending of the 5 months, right? So for June 1st, I will record the time as 2/5, 2/12. Out of 12 months, June 1st is when 5 months has just passed. So it's a withdrawal, so then withdrawal, then it's negative 3,000, and deposit 1,000 December 1st. December 1st is after 11 months has passed, and we have 1 month to come, right? So that I will write the time at 11/12, that's 1,000. Now, by the end of the year, it says at the end of the year, I'll assume that will be December 31st. The total balance is 12,982. That is a balance we call B. So we can start labeling all these notation. We have A equal to 10,210. That's the original deposit at time 0. At the end of the time, end of the year is 12,982. What about all the middle? The deposit 4,000, withdraw 3,000, and deposit another 1,000. These are all C, right? So we have 3 of the C numbers, C 2/12, C 5/12, C 11/12. I'm using the time as an index for all those contributions. So hopefully the timeline below explain all those cash flow. Okay. So now we're gonna try to follow the formula. These are the calculations for the entire formula. I actually quoted what's in the book. The formula is, maybe I should draw the formula. The formula, it says JDW is equal to I divided by original equivalent A plus summation of all the say T times 1 minus T. Now, T could be all the cash flow along the timeline. So you can see in the full formula, you have to know the I, which in this case is not given. We have the B, that was a final value. That was a 12,982. We have the A, that was the value, the balance at time 0, 10,210. And then we have a C. We have 3C. And we can go back to the picture earlier. The A is at the beginning, the B is at the end, and in the middle we have 3C, right? All those C. So you have to take your B minus A minus C minus C minus C. And so B minus A minus all the C. That's your I. That's our I, right? And we end up having an I that equals 772. Now we're ready for the computation. So numerator is the I, the interest that we have. It's the interest amount because we're calculating an interest rate. interest rate is interest amount divided by the overall deposit. Now, this overall deposit is a little bit complicated because not only do we have original deposit of 10,210, we have a couple of small cash flow in that whole time frame. Okay, any questions for the computation? Right, and you can see the A there, and then those are the C multiplied by the original timeline. Some of the key C is positive because that was a deposit. Some of the C, the negative 3,000 is a withdrawal. That's why it's negative 6,000. And then 1 minus T is really how long the money, that amount of money stay in the account. So we have a 0.065. Any question? So that's the one we are looking at the two formula here. The top one, 0.065 is more accurate. We're following this formula. The top one is calculated by the dollar weighted yield. Are we okay? There's another one, which is a simpler formula. What we did is this one, this bottom, right? And then following that, we can see the computation, which will be 2 times I divided by the A plus B minus I. And then end up having 0.069. It's not identical to the dollar weighted, but it's pretty close. Any question? Okay, so that's that one. Okay, let's see the time. We got a time. So the second example is investment for not equal to 1 year. So in our first example, the cash flow is for the whole year, but sometimes you invest for longer time period, sometimes you have shorter time period. So we remember the dollar weighted average. Always consider the entire investment period as 0 to 1. So when you see T equal to 1, it doesn't mean the one year or 1 month. When you see T equal to 1 is the entire investment period. So all the other time point along the timeline has to be like proportionate. So we have to find the proper proportion for it. So this is our second example. All right, so on January 1st, 1995, the deposit is 8,412, and then she deposited 1,000 in November 1995. So we're writing that January 1995, November 95. And then withdraw 600 on November 1997, right? And then her balance on July 1998 is, the balance is 9620. So you see I draw the balance at the bottom because that's not a cash flow, so I put a B equal to 9,620. All right, so we're gonna look at the entire timeline. So how many months has passed? So we want to look at the entire timeline lasted how many months. So exactly how many months the ending time balance at July 97. July 97, the July is a month and the July is a month and the 98 is the, how long is the time? The 98 is a year. So the beginning is January 1st, 1995. The ending is July 1st, 1998. So you get 98 minus 95. So 98 minus 95 is number of year. Number of year times 12, that's the number of months. And then the ending month is July, beginning month is January. So the number of months is 7 minus 1, that's 6. So the total number of months is actually 42 months. So from the beginning of the 8,400 to the ending of 9,620, the total time is 42 months. So all the other one is at the beginning of the month. So we wish to find out how many months accordingly. All right, so let's look at the original value is fine. The first deposit is at November 1st, 1995. So from January 1st to November 1st, how many months has passed? Since they're both first, we can just do 11 minus 1, that's 10 months. So compared to the entire time frame of 42 months, that's 10 out of 42. So I have that fraction. Then, so just want to remind that back in the dollar weighted yield calculation, the 1 minus t has to be a proper fraction. It cannot be higher than 1. So all your t is less than 1. 1 minus t is also bigger than 1, right? And so we're trying to figure out all those fractions. The second one is withdrawal of 600 on November 1st, 1997. So what's that? This November to that November is 12 months, but this November to that January is 10 months, so 12. That's 1997. So 1997 November and 1995 November. That's actually 12, 10, 12. 24 months. 24 plus 10 months. Between the January and November, that's 10 months. So 24 plus 10 is 34. That's how we get that. 34 over 12, that's that time. So I'm trying to figure out all those time. Once we have that time and then all the cash flow, now we're ready to start calculating the dollar weighted yield. Are we okay? All right, so we're gonna calculate the dollar weighted yield. Copy the timeline over here. We already have the A at the beginning, we have the B at the end, and then we have a couple of C. There was a 1,000 and negative 600. So now the I is really calculated by B minus A minus C. C has to be the total. All right, and then if you plus the 1,000 with negative 600, it's 4,000 total. So we have the interest amount. The interest amount is 808. All right, and now following the dollar weighted yield formula, JDW equal to I over A plus summation CT times 1 minus T. And we have two of the value for T, the 10 over 42 and 34 over 42. So following all those calculations, our final value for the dollar weighted yield is 0.89. That's the dollar weighted yield for the 42 months. But we may want to find the annual yield. Dollar weighted yield is actually for the entire 42 months. If you want to find the annual effective rate, you have to suppose the annual effective rate is I, then 1 plus I to the time. The time is how many years? 42 over 12 is how many years? So 1 plus I over to the power 42 over 12 should equal to the 1 plus the dollar weighted yield for the whole time frame. And then solve for the I, we will be able to find the annual yield. It's roughly 2.47. Any questions? 42 months is roughly a little over 3 years, right? So it's quite similar, right? It's like if you have the 2.47 times 4, it will be kind of similar to the 0.89. 8.9%. Any question? So that's another exercise. Let's see how far we are. And let's look at this example. See if we're able to calculate the weighted yield. Okay, you guys are online. Let me send you the clicker link so you can work on this question similarly. And that's today's attendance question. Let me send you the link. Kevin. You can bookmark this. Next time you are attending virtually, your clicker link will be the same link. Okay, try and see if you're able to follow the calculation. Here we are. All right, so first of all, we'll try to draw the timeline. Try to see. I can copy that question down. Maybe we can do it together. It's also one of the questions on actual science exams. Okay. So So timeline, the beginning time is time 0. Open balance at 75. December 31st is a end balance. Every month during the year, the association audits and for membership fee. That was the balance, which equals 60. All right, so then every month there's 1/12 deposit of 10. We withdraw 5 on February 15. Okay, so there's, it's a little bit hard to, so CI over 12, every month there is a deposit of 10. I will draw it on the timeline, it will be, and then R goes from 1 to end of every month. So that means there's also $10 deposit at 12 months, December as well. So there are 10 deposit of 10. That's one, and then we move on to the withdrawal. There's 5, February 8, so that's 2/12 time. The withdrawal is -5. And then June 30. June 30 is the end of June. That is 6 months past. So 6/12 at June 30. The withdrawal is -25. So withdrawal, I put it in the negative. And 80 on October 15. October 15. By October 1st, there has passed 9 months. So by the end of October, it will be 10 months past. So October 15 should be roughly 9.5 months. 9.5/12. And it was a withdrawal of -80. People are using this fund for other purposes, I guess. October 31st, that's the 10 months past. And then the deposit is -35. This question, the cumbersome nature of the problem might be the reason why it could be hard. So without that, we can now have our ABC. A is the original deposit. B is the final balance, and C, we have 4 withdrawal and 12 contribution, right? Okay there. So we're gonna have to, let's find the overall C. C should be all the deposit we actually have. It says at the end of every month during the year. So suppose it is 12 deposits, so that will be 10 times 12. I'll just write 120. That's a positive deposit. And we have withdrawal 5, withdrawal 25, and withdrawal 80, and withdrawal 35. So those are all the C, all the cash flow other than A and B. All right, so what would be the total? It would be 120 minus 30, so that's minus 30 minus 8 minus 110, and then minus 35. So that will be 10 minus 35. So C actually is negative. That explains why the final balance is lower than the original. It was 75, is it? I write 74 for no reason. So this is -15 for C. All right, so why do I do the calculation of C? Because we need to find the I a little bit. We are calculating dollar weighted yield. So remember the dollar weighted yield JDW is equal to I divided by A plus summation of CT times 1 minus T. Of course, T is the summation variable. T is time. So that's why we have to know the I. But in order to figure out the I, we also have to know the C. According to the formula we mentioned, that B is equal to A plus C plus I. B is the overall summation of everything. So that's why the I would equal to B minus A minus C, right? So the B is 60, the A is 75, and the C in this case is negative 15. So we actually minus a negative number here. So that's negative. That's weird. Did I calculate it wrong? How did I get 0 out of the whole thing?
Should be negative 25 and 10 minus 35.
Right, that's good point. This is 10 minus 35, so it's negative 25, and that also means this is a negative 25. That makes sense. So we have negative 15 plus 25, so then that would be 10. I would like, if the interest is 0, then what do I calculate? So 10 divided by, and we got the A, which is 75, and then here is a complicated part. It will be a big summation, right? And then all these calculations are getting, I can almost imagine how many summation we have to do. So it's going to be 10 times, that's 112, 1 minus 112. It's going to be 10 over 12. So 10 times 10 over 12, 9 over 12, and so on, right? These are all be multiplying. And then we are calculating the total deposit, the end deposit of 10. The last 10 is going to be 1 minus 1. We don't even have to calculate the last 10. So all these 10 will be multiplied by their appropriate 1 minus T. So all these 10 happen at 1 over 12, 2 over 12, 3 over 12, and then 12 over 12. Those are all added together. And then we have the negative 5 times 10 over 12, negative 25 times 6 over 12, negative 80 times 2.5 over 12, and then negative 35 times 2 over 12. So go ahead and calculate that summation, even though it's kind of a large number, see if you're able to find their interest rate. Okay, let me turn on the scanner. We can see if we are getting the same things. Okay. If you have already finished, you can submit it now. Maybe I'll sit here and try to finish the rest of the summation. All right, so it's going to be like this. First, we will try to calculate this. I want to write it here. This is going to be a lengthy process. Let's try to find space. All right, so this summation here, I'm going to do it over here, down here. So the $10 deposit happened. If it happened at 2 over 12, then 1 minus 2 over 12 is 10 plus, and then there 2 over 12. There's also 1 over 12, right? Start with 11. It's in every month. So start with 11 over 12 plus 10 over 12 and 9, 8, and then finish at 2 over 12 plus 1 over 12. So those are all the deposit for the 10. And then plus now we're gonna look at the withdrawal of 5, negative 5. It happened at 2 over 12. 1 minus 2 over 12 is 10 over 12, so it's times 5, 10 over 12, and then minus 12, 25 withdrawal. That happened at 6 over 12, which we multiply. And then the deposit of negative 80. it happened in the middle of December, so 1 minus 7.5 over 12 will be 2.5 over 12. And then we have negative 35 times, it happened at 10 over 12. Subtract that the time frame for this 35 negative is 212. Right, so that's what we need over here, because we gotta have that whole summation calculated. To make the computation easier here, it's a arithmetic sequence that has 1 over 12 as a common factor. All the rest of them with 1, 2, 3, 4 until 11. So the summation is 11 times 12. Any of them, there's 11. Right, so it's n plus n plus 1 by 2. 1 plus 11 is 12. And 12 and 12 pair. 6, 1, 5 pair. So that should be the calculation. And minus, these are, the rest is all subtraction. And we also have the common factor of 1 over 12. And then we have 50 plus, this is 6 over 12. So it's 150. That's 80 times 2.5. It's 80. 200. So that's 200. This is 70. All right, what's this exactly equal to then? All right, so we can cancel the common factor of 12. So that will be 55 minus 6. That's 200. That's 200. So it's 470. So it's 470 divided by 12. Right? So what is it? Now I feel like I need a calculator.
Give me 95%.
95
over 6.
95 over 6. Because the denominator is 12. So 95 over 6. So going back here, it's going to be 95 over 6 plus 75. So this is going to be 10 over 75 plus 95 over 6. All right, do you guys have the answer already? The interest rate, it should be a smaller interest rate. Zoom out. See what do you get there. All right. Going back to the question, let's see if we're getting the same answer. Here it is. Okay, let's see. Yeah, I see that 3 of you are getting the same answer, so I'm not gonna calculate the rest. I guess we're all arriving at the same conclusion. So that will be example on the dollar weighted yield. And do you have any other question? Okay, right. So this one we have the timeline is 1 year. But sometimes if the timeline is not 1 year, we might have to take the tax conversion. This bottom calculation is a conversion from the time frame that's not 1 year, we converted to an annual interest rate. Assuming the annual interest rate is I, and we're solving the equation for the interest rate there. Okay, so here we have another example. That's when we might have to apply the last formula for the J. You can see it has an easy formula, J equal to 2I over A plus B minus C. All right, so on January 1st, 1995, sales investment account had balance of 7,688. He deposited 100 on February 1st, 1995, and then again at the end of every 2 months. All right, so then his balance on January 1st, 1998. So originally it was 1995, now it's 1998. That means 3 years has passed. The balance is now 10,830. So that's why the timeline is kind of long. After a little while, I realized I can't not write the 100 for every month because you cannot do it for 30 times for the whole 3-year. So what happened is I did a couple of dash line. All right, so what is sales approximate annual yield for 3-year period? And you can see the word approximate because obviously to figure out the exact dollar weighted yield following a formula might be hard. All right, so here we have what we have information for. We have the A. A was what happened in 1995, January 1st. And B is the final balance, January 1st on 1998. And then it's deposit one. It go from 7,600 to 10,000. So it went 3,000 more at the end. Now he deposited 100 starting February 1st, and then again every 3 months, every 2 months. All right, as you can see that we will have to do February and then April and then June and August because it's every 2 months we have audit. Okay, and I got tired of writing them. I write 4 or 5 times, and then when I got to December, I realized it's a 2-year period, 3-year period. So now here is how we calculate the approximate annual yield. What we can do is do a simple calculation of 2i over a plus b minus I, and we should be able to calculate the I because out of the all the computer contribution, what's missing is the C. But if you only want to find the raw amount of the C, is not too hard. We have 6 deposit because you deposit every 2 months. So 2, 4, 6, 8, 10, 12. There's 6. So 600 per year. You're doing this every 2 months. Deposit 100 for so 1 year is 600, and then that's 3 years. So then the C, the overall total contribution is 1,800. So that's our C, and we have our A. We also know that B equal to A plus C plus I. All right. So now that we know the C, we know the A, we know the B, we can calculate the I. All right. Keep talking about the C, adding up all those 100 because we really don't have the I. Even if I want to use a simple formula of 2i over a plus b plus minus I have to know the I, and now the I, nothing works, whichever formula we apply. So we're gonna finish the calculation there, and so here we have it. Final balance is 10,830, and original deposit is A of 7,688. We want minus C, B minus A minus the summation of all the contribution, which we have 1,800. So we have A that equal to 1,342. And then we can use J to calculate roughly what would be interest rate. I mean, this question is not impossible, just tedious to calculate the dollar weighted yield exactly, because you're gonna have to have C multiplied by the time, right? So the entire time is the whole 3 years. The entire 3 years will have 36 months. So for example, the first 100 will be multiplied by 34 over 36, right? The second 100 will be 32 over 36, and so on. So every 100 has to be multiplied by their appropriate time. You have to do it how many times? 18. There are 18 deposits for the 3-year period. So it's a summation of 18 number. Just imagine how cumbersome to calculate GDW. The GDW requires a summation of CT times 1 minus T. So all obviously, because of computation easiness, it's definitely better to calculate a simplified version of J. And that calculation gave us 0.15626. And that is for the 3-year period. If you want the annual effective rate, it will be 1 plus J equal to 1 plus I to the power 3. The I is the assumed annual effective rate. Solving the I from this equation, we can have roughly 4.959% interest rate. Any question? So that's question that will be beneficial to have a shorter version of the formula. All right, this is the average date for contribution. That was for like this formula. If we are trying to figure out the appropriate time for contribution, and we might want to find out where that time of the contribution is. So here is one of the questions. Suppose at first you have 320,000 deposit on January 1st, 2002. A balance of 374,000 a year later. Right, so next year, and then the amount of interest earned during that year is 14,000, and the annual yield rate of the fund is 4%. Estimate the average date of contribution for the amounts. Okay, so that's like trying to figure out what time should be that contribution, and then we have to try to check what do we know, what do we not know. In this case, we have the annual yield of the fund, right? And then because knowing the fund, which means we can actually calculate the I using the interest rate. Okay, so originally we have 320,000, now we have 374,000. So we can calculate the I using the interest rate. No, there's also contribution. What do we do? We have I equal to B minus A minus C. The contribution, the amount of interest earned is, the 14,000 is given. So that 14,000 is the I. The I, we have I, we have the A. All right, because we have the A, we have I, we have basically the whole question give us BAI. CK equal to B minus A minus I, the C is 4,000. That's how we know the C. So calculate B minus A minus I to get 4,000. We just don't know where does that, roughly what time did that 4,000 contribution happen. That's the focus of the question and estimating when did we get that 4,000 deposit? That was the question. So in a way that in the formula for the interest rate, that equals I over A plus C time limits, okay? So we're assuming there's only one deposit of 4,000. We're trying to find what time that deposit happened. We're trying to find the K. In this case, we have the I is given in the question by 4%. And we have the I was 14,000, 14,000. We have the A that was 320,000. Since we have all those in thousand, we can write the equation shorter. Instead of 14,000, we write 14. Instead of 320,000, we write 320. And the C was 4,000. Instead of 4,000, we write 4. So solving that equation, we can find the K. Multiply both sides of the equation and so for K, we have K equal 1/4. Once we realize which equation can allows us to solve K, the rest is algebra. All right, any question? Are we okay? Right. Multiply both sides of the equation by the denominator and divide the 104, and then minus 320 divided by 4, and subtract from 1. So we solve the K equation. Let's see the time. All right, so basically the 2.6 focus on calculating dollar weighted yield. The reason that we want to calculate dollar weighted yield is because sometimes when you have a difficult cash flow or complicated cash flow, solving the time equation of value at that time may be complicated or too time consuming to do. Dollar weighted yield provide a roughly accurate calculation. So instead of guessing the interest rate, you have a way to get close enough calculation for the interest rate. So it's essentially a way to determine the interest rate without having to do a higher order polynomial solution. All right, now the 2.7 is the last section, and it's talking about time. The main focus of 2.7 is time-weighted yield. So essentially, it's another calculation of the interest rate. So since we already have the dollar yield, dollar-weighted yield, why do we want to calculate time-weighted yield? The reason for that is for comparison. Right, what do we do in 2.7 is determine how well the money is being managed. Here is a logic behind it. So time-weighted yield is, it allows us to quantify how well the fund was managed. For example, if the investor make large deposit right before the fund does particularly well and make large withdrawal just before the fund does poorly, then the investment yield will be considerably higher than the time-weighted yield associated with the fund. So time-weighted fund allows you to measure how intrinsically how well the fund is with or without the person's intervention. So then if you calculate the dollar weighted yield or the time equation of value, that yield from the equation that you have in 2.3 or 2.4, those yield will be higher than the time weighted yield. So time weighted yield allows you to compare if the investor is doing better than the intrinsic, like original logic of the money, or is it doing worse than that? This is something that you can compare and determine if you're doing well. All right, we might not be able to finish the entire section, but it's easy to talk about reasoning. So here, this is what we're going to draw for the timeline of contribution and balance. So we're starting to separate the balance from the contribution. Okay, so suppose you deposit B0. So B0 represents the original balance at time 0. So BT1 represents the balance at time T1. And then why do we single out BT1, the balance? Because at T1, we have a deposit of CT1, we have a contribution of CT1. Now CT1 could be negative or positive. If it's positive, that's a deposit. If it's a withdrawal, then the CT1 will be negative. All right, so what do we do here is that you first want to write down BT1 before the contribution. Then after the contribution, you have BT1 plus CT1, right? So that the vertical line, the vertical arrow down arrow there is represented just at that moment what happened to your current balance. And that is entirely caused by the manager itself. Right, and then the rest from BT1 plus CT1 to BT2. So next time, if you have any contribution, you have BT2. Now there is a difference between BT1 plus CT1 and BT2. That difference is caused by the intrinsic increase, the increased function of your value. So this is called the difference between the two is the interest rate. If the market does well, the value will increase from BT1 plus CT1 to BT2. If the market does worse, then there may be a decreasing of value in there. So those are essentially how the fund is growing in itself. But then those vertical lines are caused by the manager itself, right? So what we want to calculate, we want to grasp or capture only the part that reflect the time value, the value of the time. So then the increase factor, the growth factor, which is 1 plus JK, is in the bottom block of this equation. The first time period from 0 to T1, time 0 to time T1, that increase factor, there's no deposit yet because the T1 was supposed to be the first deposit happening. So BT1 over B0, that's entirely caused by the growth of the accumulation function itself. All right, and then from BT1 to BT1 plus CT1 to BT2, which we call BTK over that growth factor. So all the slanted line, and we would do a division to catch that growth factor. So the growth factor is BTK over BTK minus 1 plus CTK minus 1. So all those angled line, and we have a vertical arrow down, we have an angled line going up. All those angled line going up That's the direction caused by the accumulation function or the growth factor of the money, the market itself. Any question? All right, so essentially the 1 plus JK we have at the bottom, we're trying to combine all these factors that's intrinsic to the fund itself. So those are all those factors ignoring the manager itself, its impact, right? The manager's contribution is all in the down arrow, the vertical down arrow. You're adding money sometime, you take out money sometime. Those are your intervention. So we're trying to capture without your intervention how the fund is doing. So if your original cash flows, the polynomial implied internal rate, if that is higher than this rate, then you're doing better than the market, right? Then if you are you calculate, this is called time weighted yield, the JK. And we're probably gonna combine those multiple things. So these are gonna be all multiplied. 1 plus JK are going to be multiplied, but if you're doing worse than this, that means as your intervention causes the value go down instead of go up. And then actually the example in this section is gonna reflect that. It looks like time's up. We're probably going to continue from what we have here, but at least we finished the 3.6, so we should be able to calculate the dollar weighting. That will be it for today. Thank you. Thank you, guys.
Thank you. Thank you. Have a good rest of your day.
Bye.